Bonjour à tous, bienvenue dans cette édition très spéciale des DataXDays, donc édition 2020, qui a dû changer malheureusement pour passer en full remote à cause de la situation sanitaire. Donc voilà, c'est un événement qui est mis à disposition grâce à Publicis Sapient Engineering. Donc premier talk, on va commencer aujourd'hui. On aura des talks chaque mardi du mois de juin, donc un talk à 13 h et un autre talk à 17h30, puis encore un autre à 18h15. À 18h30. Donc, pour ce premier talk, en fait, on va parler d'Azureml. Donc, voilà, Paul Péton va aujourd'hui nous parler pendant 45 minutes de comment packager, déployer, en fait, des modèles de machine learning. Voilà, c'est parti. Donc, je lui laisse la main. Donc, il va commencer là tout de suite. Donc, à propos des questions, ça va être, en fait, dans le fil de discussion YouTube, si éventuellement vous en avez. Et du coup, je vais les poser à Paul en fin de talk. Voilà, merci beaucoup. À tout à l'heure.
Sorry for my very bad accent, but I hope it's enough to understand all this subject. I'm very happy to give this first session on DataXDays, but this subject is not so new in 2020 because we used to speak about deploying machine learning, but I hope to convince you of the simplicity of the scenario I will present you today. It's not a real feedback of one mission, but the summary of several experience in different companies with the same goal, which is gain value from the data. And I think that to gain value, algorithm must live outside the data scientist laptop. A few words to quickly introduce myself. So my name is Paul, and I'm a Microsoft AI MVP. I grew up in the data world with the Big Data Hebdo, the podcast. Hey guys, I don't know if you are here. I was formed as a data miner. It's a very, very old buzzword. And now I'm senior data consultant at AZURE. I'm not sure if I'm really data scientist or data engineer, but if you remember the wall between dev and ops, I'm sure that we don't have to build a new wall between data scientists and data engineers. And we can understand each other better if we have a common tool, and that's what I want to present to you. It's Azure Machine Learning. So let's merge data science and engineering. The agenda for today, a quick introduction about why and how to industrialize machine learning. Part one, quick overview of the user interface, the studio Azure Machine Learning, the MLOps approach in a few words, and after that, demonstration with three workflow, including grid search and pipelines, working with the Python SDK called Azureml. So because it's not so simple to demonstrate some script on YouTube, I propose to you to go to my GitHub. There's a specific repo. We will publish the link by maybe on Twitter after the session. And if we have enough time, I've got one or two surprises for you. So why industrialize machine learning? Not because it's proof of concept is old-fashioned in 2020, but because it's a real return on investment with data. And what the advantages of industrialization? I think it's to version the models, to have backups, but to plan, to execute, to plan the job executions, to monitor the services, and to integrate all the security rules of the organization, like authentication, token, or keys, security keys, and maybe edge deployment. What we need for production, as we say, is that there's no silver bullet, but we can draw up a list of the elements necessary to to put into production. It's my wish list based on my experience, and try to do yours. But I think we need a scheduler to plan all the steps: data cleansing, training, retraining, and the forecast maybe in batch. We need a storage system to archive the models. It's very, very important. Maybe we have one version per algorithm, per hyperparameters values, or maybe per training dataset. So we can have many versions of just one model. And we need to store these models in a serialized format. You know, I think if you use Python, you know the Python format, which is one example of a serialized format for the models. After that, we need a tool to expose the model, and REST API is very, very common tool, well known by all developers. But we have to secure the access, maybe with a key token or authentication by LDAP. And resources can have to be deployed at scale because we hope that many people will use our model in production. To help with the scaling, it's maybe, I think, a good way to use containers like Docker images, and my best environment to do that is the public cloud. I would like to present to you today Azure Machine Learning, which is the combination of two parts. Some Azure services to storage services, compute services, a key vault for password and monitoring services. But it's an SDK, so a development kit in R or Python, to script all the steps we are going to work on, and to make the link between all the services in our complete workflow. Just have a look at the user interface. It's ml.azure.com. After you provision a resource in your Azure subscription, it's okay. It's visual. We can have a look on the logs, on all the data sets, the resources we use to compute. But it's better if we do all these operations with code, and I think it's a better way to reach MLOps. Just one word on the licensing. There's two options. The standard one, which I will use today, and the enterprise licensing, which opens some features like automated ML in the UI, and a designer, which is something like, if you know, DataXDays DSS. What about the tarification? You pay as long you run the virtual machines and clusters of virtual machine, or virtual machine for the exposition service, and so it's near the cost of the virtual machines. Depends of the RAM and the CPU or GPU of these machines. For a classical data project in the cloud, or maybe not in the cloud, but here it's with Azure resources, we can have 4 classical steps. The first one is to ingest the data, and we can use Azure Data Factory to trigger data ingestion. We store all the data in at least two layers on maybe the data lake. The raw layer is just a copy of the data sources, and the clean layer, it's a result of maybe Python or Scala R scripts for data cleaning. But we can run ML training and scoring evaluation on the compute resource. With this architecture, we have two ways to expose the data. The first one, it's the classical one, it's reporting dashboards, maybe with Power BI. But today we are going to talk about predictions, how to expose predictive machine learning models, maybe on a web app and supported by, orchestrated by Kubernetes. And here in our toolbox, we will find Jupyter Notebooks, Jupyter Lab, or Visual Studio Code if you prefer an IDE. We can have an infra as code approach with our RM template with or even if with the notebooks to deploy automatically in several environments, development or production. And specifically to MLOps, we can use container registry. It's to store Docker images with the models. And we will use Azure Machine Learning. And I will show you that we can use another open source product, which is MLflow. So that's the big picture, the overview of the global architecture of the project, but we are here to speak only about Azure Machine Learning. A quick and concrete definition of MLOps, maybe in parallel with DevOps. If DevOps is reproducibility and testing of the code and automatically app deployment, we can transpose all these concepts to machine learning. The central object is the model, and we have to reproduce the model, to validate it, to deploy it, and make it consumable by some API. And we have to retrain the model. We will conclude about the silent failure of models in production. For all the demo, I use a very simple dataset. It's a kind of toy model, we can say. It's about diabetes. It's a scikit-learn dataset, I think. We just want to explain the Y value, which is a numerical value, by 10 other features, all numerical features. So we are here in a classical regression. I will work with a linear regression and regression, but it's not the main point of the session. I think you know very well the data science workflow: training, packaging, validation, deployment. But don't forget that we will after that retrain the model, maybe to do better or to adapt to the drift of the new data. But to train, maybe two tips. I think you know that too. But I will show you how to use these tips in the Python SDK. Automated machine learning, it's some kind of brute force, and to find the best model, and hyperparameter tuning to find the best combination of hyperparameters. So let's go to the real subject of today, which is a Python SDK, Azureml. So I just use the Python one and not the R version, so I can't have an opinion on it today. The Python Azure SDK is just a set of libraries to access to the components of Azure, like a virtual machine, clusters of virtual machines, Docker images, and it will help us to communicate all these services. There's an official repo on GitHub, and you can install it very easy with classical pip install. maybe to have an overview of this new SDK and all the objects we can find, not all the objects, but the main objects we can work with in our scripts. I would like to define some concepts. The first one is the workspace. When you buy another resource, Azure Machine Learning, it's one workspace. One workspace is for maybe one data science team, one or maybe several projects on the same, sharing the same data sets and the same compute resources. So it's the global object, and we will interact with all this workspace and see all the other objects in the UI. So first, we work on maybe a Jupyter Lab. We write some notebooks in Python. We have to execute the scripts. We can do it locally on a virtual machine, but if we need some power, or maybe more compute power to execute the scripts, we need target compute. Well, target compute is just a cluster of virtual machines. This target compute has to communicate with the data store. I will later show you which data stores are available now. When we launch a script, that's what we call a run inside an experiment. You can understand the experiment like just the project on which you are working. You can have many runs inside one experiment, and many experiments inside one workspace. And that's for the training, but we don't forget the deployment step. And we need to register the model, the best model we can get from the training. And after that, when the model is registered, we can easily deploy, first create a Docker image, and after that deploy it to make prediction, maybe with a web app, a web service. And we will define an endpoint, termination endpoint to make prediction. So what are the supported storage in Azureml? Oh, it's only at the moment it's only Azure resources, file system like blob container or data lake, or the DBFS, Databricks file system, or it's managed DB database, but not only Microsoft SQL Server database. It works with Postgre and MySQL. Here is just a sample of code to define a dataset with a class called dataset. You can see that it's not directly a pandas data frame, but you can convert it and work on it as pandas data frame. Just a quick tip to find the best model without only with brute force, maybe. I would want answer to the question which is the best today, is data scientist or machine learning, but you have to know that automated machine learning work with parallel compute, so on a cluster. We can define stock criteria, and just a sample of code to show you that we define the primary metric, evaluation metric, to rank all the algorithm. We can use cross-validation for evaluation, and all maybe 20 or 30 algorithm will run in parallel on the cluster, and after that we will have. I hope I got the screen I think it's later. I've got one screenshot about the result, but it will rank all the algorithm based on the primary metric, and we can find the best model. And what's the solutions to deploy the best model? 4 solutions. The simplest one is a web app, classical web app in Azure. Maybe we can use serverless principle as a function, but be careful because it's at most 5 minutes of compute. And for development scenario, but with authentication, we can use Azure Container Instance, and maybe the bigger one, but be careful on the cost of this one. It's Kubernetes for production scenario with authentication with Active Directory, but at least 12 vCore CPU are needed. So with all these tools, I will show you 3 complete workflow to deploy, to go from dataset to deployment. First one is maybe the most simple, but it's simple because we are working with scikit-learn, Next, or TensorFlow. But even if it's simple, we have 6 different steps in the script, but really easy and always the same code. You can clone my GitHub repo and you have all this code to go quickly. First we just make the link with the workspace. Maybe we can work on our laptop. It's not necessary in the cloud, and we can link with the workspace. In the workspace, we define one experiment. It's about diabetes. And the first thing we need to work, it's one dataset. So we just load the dataset and convert it to a pandas one. And after that, we can use some classical script of scikit-learn pandas methods. It's the same as usual. So two classes of the SDK which are very important to deploy the model. We have to register the model. Look at here the framework, scikit-learn, and the version. And here I give 2 information, which are the size of the machine to expose the model. We will come back to this notion later. And last step, we deploy the model, and after that we have an endpoint to consume the model. I just want to maybe to go quickly. I don't know, but maybe with screen share it's easier. When the service is up, we can find the URL which we will use to make prediction. Here we can see that it's a scoring URL. We have some documentation at the Swagger format. So you can use a tool like Postman, maybe if you want to use the endpoint, but here it's just a run on the service with a Python script. We have 10 features in the diabetes model, so we create a quick dataset with two rows here, and we run the service, and we can get the prediction. So it was, I think, the easiest way to begin with Azureml, but that means that you use a very simplest way, a very simple way in training and in scoring. If you want to do some custom model, but it could be in scikit-learn too, we have to add 3 steps here. So before, after the model registering, we have to define our own scoring script. We have to list all the dependencies. That means the packages we need in the scoring script. Yes, we will have two functions in this script. First one is to unpickle the model. We will upload the model, the serialized model, in the function. We will unpickle, if it's pickle, will with a joblib package, we will unpickle the file, and we will define the predict function to get the score. So we need some package like joblib, like maybe scikit-learn if you have more data preparation in the script. The inference configuration, it's just the link between this scoring script and the package we need. And we define RAM and CPU we need to do on three ways. Local one, and it's quite difficult because you will launch a Docker environment on your machine, so it's not so easy. But you can work with container instance on Kubernetes in Azure. To sample of code for these steps. This is a definition of the environment. You can see here all the packages, the dependencies I need. There's many ways to get these dependencies. Is with install with Conda, and to deploy on the STI container instance. I give 2 informations: the CPU cores and memory in gigabytes. But I can do better than just give one vCPU and 1 gigabyte of RAM. I can run the profile method on the model, and it will run a new run in the experiment, and give me the information of the best with some sample of data, the recommended memory and the recommended CPU. So you can see that I can do better than 1 and 1, just 0.5, and costs are divided by 2. In the Jupyter, we can launch some widgets. Widgets are easy to look at the logs when we launch a run, or maybe a long step like a deployment. But remember that what we have here, this widget, it's the same thing as the UI. Maybe so remember, we work with code, but bad luck. But we work with code in Jupyter, but we have all the results in the UI. So I can find an old run of the experiment. I can find some metrics I record during the experiment, and hyperparameter value maybe. So let's go to the slides. And last, what I call the big data workflow, because we maybe we need some more compute power to train our algorithm. If we do some deep learning, or if we work with many big data. So we have to work on a remote cluster to train the model, and to do that we have to make the link with this cluster, and we have to send to the cluster our training script. We have to send package dependencies. It's just a YAML file which contains all the list of all the packages we need. The estimator is just a concept to maybe as like the inference configuration is just to make the link between these three steps, and after that we can monitor the run which is going to happen on the cluster. Just one extract of one sample of code to show you this estimator. So remember, the thing you have to understand is that we are going to train remotely on the training cluster, and not and it's very a good solution when you have you need to run maybe some script in parallel, like in a grid search. What does that mean? Monitor the run. You want to have some results, some evaluation of your training. This is this score, for example, and it's very easy because you just have to log with this method .log. You have to log some information during the training. You can log some values, numerical values, but you can log what we call an artifact. It could be maybe an image or a pickle file. And if you know the open source solution MLflow, you can use it on Databricks. It's available in Azure Machine Learning too, and you have to just to set tracking URI to work with MLflow like in Databricks. If we have a cluster of virtual machine, it's a good idea to think about grid search. So to define parameters space and to find the best values of these hyperparameters, which one criteria which is the metric to optimize. But we can define also termination criteria like total number of runs, or maybe a duration. And that's the widget I would like to show you. When I do grid search with the class hyperdrive, I can rank all the models like in automated. It's the same as automated ML. We can rank the different models based on the matrix or based on the duration. And at the end of the grid search, we want to get the best model. It's very easy. Some methods are here to get the best model. And with the best model, we will register this model and deploy as I showed you before. If you are familiar with the pipelines, and maybe in scikit-learn, you know that it's a very good way of thinking when you do some data science or machine learning process, because you can divide a global sequence into steps. Sorry, I think that my neighbor is knocking on the wall. So I don't know if you sure this. So okay, so with we've got an object called pipeline in Azureml, and we can define steps. We can have a look on the UI and the user interface steps here from the dataset to maybe the deployment step. Pipeline is interesting because you can schedule a pipeline, but remember that sorry, I will go back. But remember that you it's an object that you can trigger from Azure Data Factory if you have a global, more global scheduling on all your data steps. So I think that we have all the tools to do a full MLOps pipeline. And we can imagine some scenario like A/B testing. We retrain, we monitor the results. We try to retrain on new data, and if the metrics are better, so we deploy the new model and continue to monitor. It's time to conclude. I think that the advantage is the duality between code and UI. We can have our favorite tools like Jupyter or RStudio in just one click. But we need maybe some other connectors for data sources, maybe GDBC or DBC, because today we are limited to Azure sources. Maybe the functionality, the feature I want to have in this interface is to integrate easily a feedback loop to know the opinion maybe of the users of the model. So the good scenario with this tool, I think, it's when you have your data are already in Azure storage. When your data scientists know Python, it's not so difficult to use the new classes. But be careful, you have to manage your Azure resources and to contain the cost. And because I go quickly, two good news in this SDK. It includes some tools to make explainable AI to interpret the black box of the model. You know that the more complex is your model, the more more difficult is it to interpret, but it's today we have many tools like Lime or Shipley values to help us to interpret the model. Just want to show you an example with the Shipley values. It's based on the game theory, and it's very easy, and it's saying us that the feature S1 is the most important in the diabetes regression. And another good news, but be careful because it's an enterprise feature and it's in preview, so it's you have to pay the enterprise license to get it. But you know that the input data could change and leads to the degradation of our model. So we can, based on something like the drift coefficient, I remember the Pearson's fee from my studies. It's near the same notion, but with this measure, you can monitor your model and know which feature is contributing to the degradation of the model, and you will receive an alert by email. So maybe a few minutes for Q&A. I will look at the chat on YouTube.
Alors, pour le moment, on n'a pas de questions. Merci beaucoup pour ton talk, Paul. Voilà, donc pour le moment, on n'a pas trop de questions. Voilà, je pense que tout a été clair, éventuellement. Je sais pas. Donc, si vous avez des questions, n'hésitez pas à les poser. Voilà, je les pose tout de suite à Paul et il va répondre. Oh, bah, écoute, je pense qu'il n'y a pas de questions. On peut éventuellement parler des talks de ce soir. Donc, on a eu un échange de dernière minute hier. En fait, on a dû placer le talk de cet après-midi pour 13 h et celui de 13 h pour cet après-midi à 17 h 30. Donc, cet après-midi à 17 h 30, on a Johan Jublan et Julia Bianchi qui vont nous parler en fait de la partie sécurité d'un modèle de machine learning. Ça va être très intéressant. Et à 18 h 30, on enchaîne avec Florent Ramière pour nous parler en fait des bases de données en fait pour les passer en fait aux plateformes en base d'événements. Donc ça marche. À ce soir, merci beaucoup. Merci Paul, merci à tous. À ce soir à 17 h 30.
Merci.
Au revoir.